In lesson 18, we're talking about combining like terms, and we're going to learn how to identify like terms, and then if they are alike, to be able to combine them within a variable expression. A like term would be terms that have the same variables. They must have the same variables, and they must have variables that have the same power. So they must have both the same variable and the same power to be alike. If a term has different variables or the same variables with different powers, then they are unlike terms or dissimilar. And if they're unlike terms, you cannot combine them. They cannot be added together. The coefficient of each term does not affect whether they're alike or not. So here we have x to the fourth, and the third term here is x to the fourth. So the same variables with the same exponents, so these two terms are alike, even though one has a coefficient of 3, the other has a coefficient of 5. That's fine, they're still alike, and when we combine them, we'll actually add the coefficients together. So you have a positive 3 and a positive 5, you get positive 8, and it maintains the variable x to the fourth. So the variable doesn't change, the exponent doesn't change when you combine them together. This third term here in the middle then cannot be added to that, so you would simply write it along with the rest of your expression, and that's how you would simplify that expression. So just to kind of give you an idea of how this works, if we think of this with 3 apples here, we have, let's see, we have 3 apples here, and we have 3 apples here. We add that together, obviously, we get 6 apples. On the other hand, we have 3 apples down here, and we have 3 oranges. They are different, and we can't add 3 apples and 3 oranges together and get a certain number of apples. Obviously we still have 3 apples, so the oranges don't affect it. We can't combine them to say we have more apples than what we started with. And the way this works then algebraically is very similar. So if you have 3x and you're adding 3x to that, then you would get 6x. We can combine that together to get our total. On the other hand, if you have 3x here and 3y here, you cannot combine them because they're not alike. So you would not have 6x's, you would simply have 3x and 3y. So the way this works in simplifying algebraic expressions then is we need to first of all identify our like terms. With letter A, you have an x term and an x term, same variable of 1, and so these are like terms. They can be combined. So then we look at our coefficients, 5 and 7. We would add them together. 5 plus 7, of course, is 12. And our variable x. So the simplified expression is 12x. With letter B, what we're going to want to do here is simplify these signs right here. If you recall, subtracting a negative is the same as adding the inverse. So if we rewrite this in simplified form, we'll have negative 4y plus 3y plus 5y. Now you'll notice that all 3 terms are y terms. Same variable, same exponent. The coefficients are different. That's fine, but we would add our coefficients together. So you've got a negative 4 plus 3 is negative 1 plus 5 would be a positive 4. So this is going to be 4y, and that's the simplified expression for letter B. With letter C, you have an xy term here. This one, the second one is an a term, so that's totally different. It has different variables. But notice this third term. With the first term you had x and y. This one you have a y and x. Now those are the same because when you multiply, it doesn't matter what order you multiply things in according to the commutative property of multiplication. So we could rewrite this as 4xy, and you'll notice that that is a like term to the 6xy term. So we can combine 6xy plus 4xy. So you add your coefficients and you're going to get 10xy. And then you would simply write your other term that cannot be combined, and that is your simplified expression for letter C. With letter A here, this is just some more examples. You need to first of all identify your like terms. Now notice we have some exponents. So you have x to the fifth, and you have x to the fifth here. So those have the same variables with the same exponents. So those are like terms. Now, what are your coefficients? Well, when you have a term with no number in front of it, your coefficient is understood to be 1. So each of these have a coefficient of 1. And if we're to add our coefficients, 1 plus 1 is 2. So that gives us 2x to the fifth. And then we have our y cubed term here and a y cubed term with coefficients of 1. 1 plus 1 is 2. So that gives us a positive 2y cubed. And that is your simplified expression for A. With letter B, you also again have k squared, k squared, k squared. Those are all alike. And then here you have kx to the fourth and kx to the fourth, so those are alike. Let's first of all add our k squared terms. You will notice that you have a coefficient of 3, and then here you have a coefficient of negative 2. Keep in mind that when you have a sign like this, a minus sign, it goes with the term that follows. So we need to consider that as a negative 2. So 3 minus 2 is 1, plus 4 gives us 5k squared. And then our other like terms, you have coefficients of positive 2 and positive 1. 2 plus 1 equals 3. So that's going to have a coefficient of 3, kx to the fourth. And that is the simplified expression for letter B. With letter C, you have an x squared y cubed. And here is also an x squared y cubed. Even though it's written in different order, it's multiplication. The order in which we multiply doesn't matter. So those are similar terms. Those are like terms. You also have xy here and yx or xy there as well. So let's first of all add our x squared y cubed has a coefficient of 2 and a negative 8. Remember that sign there goes with the term that follows. So 2 plus negative 8, or 2 minus 8, would be a negative 6 x squared y cubed. And then you have a coefficient of 1 here with the xy and negative 5. 1 plus negative 5 is negative 4xy. So that is the simplified expression for letter C. In this real-world example, we have the Olympic competition that offers these 3 equestrian disciplines, and it gives us a diagram of the arena and asks us to find the perimeter. So we're looking for the perimeter of the arena seen in this diagram right here, and they want us to find the expression, or evaluate the expression, if x is 19.5 meters. So let's think about this for a minute. If we are trying to find the perimeter of a rectangle, how do we find the perimeter of a rectangle? Well, that's going to, you're going to have 2 lengths, so 2 times L, plus 2 widths, so 2 times W. So that's how we would find the perimeter of a rectangle. And if our length is 3x plus 3, we're going to write 2 times 3x plus 3 for our length, plus 2 times our width, which is going to be x minus 1. So now we've set up our expression, and so we need to simplify it. To simplify our expression, we're going to need to distribute 2 times 3x here. 2 times 3x is 6x. And then 2 times 3, we distribute that, is going to be 6. And then we have 2 times x we're going to distribute, and that's going to be 2x. And 2 times a negative 1 gives us negative 2. And so we've distributed, and now notice we have like terms. So the 6x and the 2x are alike. We would add our coefficients together to get 8x, and 6 and negative 2 are alike. They're constants. They don't have variables. That's fine. But we can add them together. 6 and a negative 2, or 6 minus 2, will give you plus 4. So that is the simplified expression for the perimeter of the arena. Now we're going to use that then to find our perimeter, given that x is equal to 19.5 meters. So if we put that into our expression here, it's 8 times 19.5 plus 4. Now to quickly multiply that in your head, 8 times 19.5, let's say 8 times 20 would give you 160. Half of 8 is 4, so you got to subtract that from 160, so that's going to equal 156. And then we're going to add 4 to that anyway, and our perimeter is going to end up being 160, and our label is meters. So the perimeter of the arena is 160 meters.